This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day, wherever you're listening from, and welcome to IAQ Radio Plus. This week is episode 595. We look forward to an excellent interview with Lew Harriman about the new ASHRAE document. That's going to be called Damp Buildings, Human Health and HVAC Design. Before we start, though, we need to thank our sponsors. They are the reason IAQ Radio is still free.
IAQ Radio Association sponsors are the American Conference of Governmental Industrial Hygienists. Learn more at acgih.org. The Cleaning Industry Research Institute. Learn more at ciriscience.org. The Indoor Air Quality Association. Learn more at iaqa.org. AIHA, Healthier Workplaces, a Healthier World. Learn more at aiha.org. And the Restoration Industry Association. Learn more at restorationindustry.org. IAQ Radio industry sponsors are AEML Laboratories. Learn more at aemlinc.com. Particles Plus. Learn more at particlesplus.com. And Healthy Indoors Magazine. Subscriptions available at healthyindoors.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man with this week's IAQ Radio Trivia question.
Hello, everyone. Congratulations go out to Doug Conan, Aerotech Environmental in Dayton, Ohio, who was first to identify aerosol, direct contact, fomite, oral, and vector as the 5 main routes of disease transmission. The IAQ Radio Trivia question for today, Friday, August 7, 2020, has been sponsored by Ideas, a solution chemistry company providing unique solutions to odor removal, surface cleaning, and decontamination problems. Here's today's IAQ Radio Trivia question. Name the 2 ASHRAE documents that provide key guidance on ventilation requirements for healthcare facilities. Back to you, Joe.
All right, thanks, Cliff. Hey, before we go to Lew's intro, I want to mention the RIA virtual conferences October 6 and 7. Fragmented No More is what they're calling this year's event. You can learn more at restorationindustry.org. All right, Lew Harriman. Lew is a contributor to the EPA Guidance for Moisture Control in Buildings, the EPA's Guidance for Air Cleaners, which is actually really good, and we haven't had a show on that yet. They've revised that air cleaner guidance document. And most recently, the one we're going to talk about today, the ASHRAE Special Publication titled Damp Buildings, Human Health and HVAC Design. After college and a 5-year stint in the Air Force, Lew worked for a manufacturer of industrial dehumidification systems for 10 years before a second 32-year career as a humidity control and building forensic consultant. He operated his one-person firm under the name of Mason Grant until 2018, when he retired from active consulting and took the tongue-in-cheek title of Emeritus Director of Research because he says he likes the sound of it. Still, he seems unable to offload his attachment to ASHRAE volunteer work since he continues to serve as a humidity and filtration consultant to ASHRAE's COVID-19 Epidemic Task Force. Welcome, Lew. Great to have you back.
All right. Thank you very much, Joe. It's a pleasure to be here.
It's always great to have you. We were looking back, and it's been over 5 years since we had you live. We've replayed a few shows, and you've retired or trying to retire since 2018 now. How's that going, Lew?
Well, I'm making progress on the retirement front. Spending a lot more time in my basement workshop trying to bring it back to life so that I can actually do woodworking, which I love to do. Plenty of contact with grandchildren, which is always a delight and a joy, and then, occasional things for friends. A little bit of work for ASHRAE as a volunteer, as you mentioned, and also helping out the ASHRAE committees to try and figure out how to implement some of these new standards. So,
You know,
usual stuff.
you've been really a big ASHRAE volunteer, proponent of ASHRAE over the years. Why do you think ASHRAE is such an important organization to the world? I mean, not just the indoor air quality or building science segments of the world, but in general.
That's a good question, and I think the answer is that it's not a typical organization. It's if you think about organizations of its size and of its character, it's all volunteer, except that we all pay to be volunteers. we pay to be members, and then we pay to go to conferences, and we spend our own time to write standards and also to communicate with our colleagues about best practices. So it's an odd thing, and I think internationally people sometimes have a difficult time gripping this. I spent some time as an ASHRAE lecturer, and internationally people are confused by this because they assume that it's the U.S. government that's paying for all this stuff, and of course it's not. it's
Okay.
you and me paying for that. But I think that's part of it, is the spirit of volunteerism and the part of non-commercial volunteerism. Always difficult line, tightrope to walk there with respect to non-commercialism. But I think it's unique, and it's fun. It's a lot of fun to talk to colleagues about mutual problems and mutual solutions. So it's fun. It's credible. Do a very careful job of trying to have only the consensus best judgment about things when it's published, and that's always shifting. But I think the organization does a pretty good job. It's a privilege to be part of it.
Interesting. They also have a big effect because a lot of the standards anyway are designed to be written into code. So, when you do something along those lines with one of the standards and even these publications, it gets a wide audience, a lot of respect, and I think it makes a difference.
Well, and I think to your point, in terms of a wide audience, I was listening to some folks talking about the COVID-19 task force that ASHRAE has, and one of our colleagues was talking about the traffic on the ASHRAE website. So in 2019, there were, in round numbers, about 810,000 hits. 810,000 hits, and that's over a year. And then in the first 4 months of this year, excuse me, the first 4 months of this year with COVID-19, there were 550 million hits on the ASHRAE website. So the organization is reasonably well sought after in terms of international attention on this problem. We're trying to do a good job of collecting and organizing information that's helpful to people with respect to buildings and COVID-19, which turns out to be the big challenge. Outdoors, not so much of a deal. It's the indoor environment that is yielding the big infection rates.
Lew, this new document on damp buildings, human health and HVAC design, why, you're retired, you put a lot of time into this document. Why do you feel this was such an important document?
Well, it's that this comes out of a task assigned by the ASHRAE Board of Directors. In 2013, they published the ASHRAE position document on indoor dampness and avoiding indoor dampness and indoor mold. And in that position document, they called for a large group of things, better information, more focused information within the ASHRAE handbook series about this problem. And they also called for a better definition of what level of building dampness is likely to lead to a problem. It's all very well to say, don't have a damp building. It's a little trickier if you then want to know, what would that be exactly? How do I define that? How do I quantify that? How do I recognize it if I've got it? So the ASHRAE Board of Directors convened a multidisciplinary task group, and that meant that for the next 3 years, a group of us spent a lot of time and a lot of effort looking at the epidemiology and also the best practices and also typical practices and what's really a problem, what's not likely to be a problem, and then put that in the report. So it's the collected experience of those within ASHRAE and outside of ASHRAE who are focused on this problem. So it's useful because it represents a lot of people looking at this over a lot of years and then trying to focus that and put it in one place.
You know, it also contains some good, solid, advice that you can use in the field, which is not always there in some of these documents, especially with the dampness documents. They're oftentimes it's tough to tell what dampness is, and you've done a good job in here of trying to determine that. I just have a question though on the title, because you're talking about dampness, human health, and HVAC design, but to me, it's much bigger than just HVAC design. What you've put together here, why wasn't it more the title a little wider?
I will say that was a collaboration between our task group. I was the chair, but we have a lot of other people in task group. It was a collaboration on the title between the task group and the special publications group within ASHRAE, and recognizing that this is an ASHRAE publication, right. Recognizing that this is primarily designed for the membership of ASHRAE and also the people that looked to ASHRAE for documents, who were largely HVAC people. We didn't really think that it would be productive to say dampness in all its respects for all time for architects and everybody. The idea was, if we're going to get distribution on this, let's make sure that it's clear to the primary audience that it is for them, and that it will be helpful for them in communicating what ASHRAE knows about this to the other sister and brother disciplines. So you might call this title an effort at more effective marketing of the information from ASHRAE to the membership, and therefore to membership can help carry it out to the rest of the world.
Okay, fair enough. And this is a special publication and not a standard. Could you talk a little bit about that, why that's important to note?
Yeah, it is important to understand what this is, what it is and what it's not. Okay, so what this is it's a special publication. It's the collected understanding of ASHRAE members and the multidisciplinary task group from people from outside of ASHRAE, building owners and public health investigators and epidemiologists. It's the collected understanding of what leads to an increased risk for dampness related problems and what's not likely to, and what you can do about it. So it's not a standard. It's not a building code. It's not an ASHRAE standard. It's not written in code language. ASHRAE standards now by board policy now have to be written in code language so that it's easy for code officials to put the standard directly into building codes. And this is not that. This is a special publication, the collected understanding of what is and what is not relevant with respect to dampness in buildings, with respect to health, not just dampness, but health relevant dampness.
A little later in the interview, I think it has led to some, I don't know if it's changes in standard or additions to standard, but we'll talk about that a little later in the interview. And before we do though, I'd like you to kind of, if you would, summarize what your key points are from this document.
Sure, you betcha. Several key points. And I could probably go on for a very long time about this, which I don't want to do. I want to get the questions and so forth and the interaction as much as possible here. But number one, damp buildings do increase the probability of health risks. That's a very clear association. and increasingly getting closer to understanding the causation. But the association is very clear. If you have a damp building, then you're likely to have increased risk of unfortunate consequences for some people at some times. That's number one. There is a relationship quite clearly. Number two is that really buildings are quite fault tolerant. They can stand a lot of abuse with respect to moisture and humidity, but they can't withstand that all the time. The problems are likely to happen when these conditions are what we now defined in this report as persistent. And I want to explain that here in a minute. But it's, if dampness has become the normal thing, then that's a problem. And that's almost certainly going to be a problem over time. If it's not the normal thing, if it isn't persistent over time, then probably it's not going to be something you should get too excited about for most people. What that means is that designers and owners really can avoid this kind of problem with a little bit of thought and attention, as long as they don't treat dampness as, it's normal in this kind of building. These buildings are always damp, or well, this climate, it's damp in this climate. It's just going to be damp. And it's like, no, that's not. That's when the problems occur. Is when dampness is accepted as a normal condition. So that's kind of key. Want me to talk about persistent? The word persistent here.
Well, before you do, I just want to let listeners know, because we probably won't have a lot of time to go into the section you did, and Mark Mandel was a big part of this and others, on the health effects. I've read all these documents, Lou. I mean, I read them all. I must be crazy, but I do. And I got to tell you, you guys did an excellent job of taking the current knowledge and kind of putting it all together, and then spitting out what dampness is and how the dampness affects health effects, the most current reason. There were things that I don't recall seeing in other documents in that document that were really, really right on. So I thought that part was just excellent.
Well, thank you very much. That's we tried to get the best input from everyone that we possibly could, and then the challenge is to take all that input and compress it to the point where it's actionable.
Well, and I think what I would like to do, and I don't know if this is possible, but I would like to take some of that information and incorporate it into some of the presentations we do for, people that do indoor environmental quality investigations and so on. I mean, I just think it's really well done, and that you bullet point highlight, here are the key issues with dampness in buildings and health. And then you also take it and you discuss the variables there. So some people were more susceptible than others, and things of that nature. So I thought you did a real nice job there. But let's talk a little bit about what persistent dampness is, and what you mean by persistent dampness. How do we define that?
Yeah, it's there are two important words in this report. One is persistent and the other is abnormal. And we spent a great deal of time within the group deciding how we should define this, because again, it's very clear from both the literature and all the collected experience of everybody that buildings can take a lot of problems. You can have a lot of water spills. You can have high humidity indoors, high RH, high dew point even, without it being a big deal. Buildings survive this. Right? We're comfortable, we're okay. The building doesn't rot, it doesn't fall apart, it doesn't grow mold, doesn't grow bacteria. Well, actually, grows a lot of bacteria all the time, has a lot of fungus all the time, but not so much that it's a problem. So persistent is what we decided to say there, is that the condition has become typical. In other words, it extends for days or weeks at a time, rather than infrequent excursions of a few hours per week above some suggested quantitative thresholds of concern, that the early warning signs that we put in. So in other words, persistent means it's going to be that way a lot, and it's not going to be occasional excursions into slightly more risky areas. So that's number one. That's what persistent means in the context of this report. It's become the normal. And the word that we use here too is abnormal. So what is abnormal conditions? Well, there's a lot of, we have early warning signs, the early warning metrics that people can use to associate, things that they can measure without too much difficulty with early warning signs. And we decided that we would set those at normal conditions. What's normal? We set it at the upper boundary of what we consider normal. So what does that mean? It means abnormal. These are conditions that they can occur with some regularity in buildings and probably do. Okay, but no designer says, I'm going to design a building to have these conditions as the basis of my design. All right, so abnormal means conditions that designers are not going to use as this is going to be a great building.
Yeah. Yep.
That's what abnormal means.
All right. And you talked about early warning symptoms in the document, which I think is it's an important, I guess, distinction, because you're not saying that every time we have these conditions, there are health issues. These are early warning symptoms that may well lead to health issues for occupants. Is that said somewhat along the lines of what you were trying to get through here?
I couldn't have said it better. That's great. They're early warnings. They're if things keep on going like this for a long time, then probably a risk, and over time, and especially if you have a lot of these things, all four of them at the same time, then that's something that it really ought to pay attention to, because abnormal conditions have become normal, and I don't want that.
And let's go through those four, early warning symptoms, Lou. And I have to agree with you. I've done a lot of inspections over the years, and normally when we find people are complaining about health issues, we find more than one of these issues, not just one. But I'm not saying that couldn't happen with just one of them, but it's much more common in my experience to see multiple symptoms like what you're going to describe right now.
Yeah. I think for most of us in the indoor air quality investigation business, and many I know listeners are do that. I think that the first one I'll talk about is wood moisture equivalent. So with your moisture meter and looking at gypsum board and, let's say, ceiling tile, whether it's cellulosic things or wood for that matter, we set a threshold of concern at 15% wood moisture equivalent. So why? I'll explain each one of these individually, but I'll go through all four of them first. So first one is above 15% wood moisture equivalent. The second, which is related to that, is a persistent surface relative humidity or water activity above 0.75, 75% equilibrium relative humidity measured at the surface, not in the open air. Okay, number two. Number three, equilibrium relative humidity in concrete or in masonry above 90%. So, equilibrium relative humidity, you're going to do the ASTM test and drill a hole in there, and then you're going to measure relative humidity in the hole. A lot of procedures there, controversy, but above 90%, that's probably not going to be what a designer is going to assume is going to be something good. And above that, you might get moisture transfer to the cellulosic materials nearby or in contact with it. So that's probably not a good idea. And also, and from an HVAC design perspective, a persistent dew point temperature indoors above 60 degrees Fahrenheit. So each one of those, and especially for designers, that 60-degree Fahrenheit dew point that's not what you'd use for design. That's begins to be an abnormal condition. Same thing with wood moisture equivalent above 15%. You're not planning on having wood moisture equivalent in the 20% range, for building materials. Above 15, probably an indication that things aren't normal. Want me to, yep.
Well, I was going to say there that several of these are pretty easy to measure. Others are not so easy to measure. So for instance, the equilibrium moisture content at the surface of materials, or the water activity. You had an interesting way of having people measure that, and I want you to, if you would, explain that for listeners.
Sure. What I recommend is that the first and most important ones from a practical use point of view, if you are in a building, is to look more at two. I'm going to answer your question, but what I'd like to encourage everybody to do from a hierarchy of concern is look at that 60-degree Fahrenheit dew point over time. That's really easy to do with building automation systems and reporting systems. So if that's normal during normal operation, especially if it's normal after hours, then that's easy to see, easy to measure reliably, and easy to do something about in almost all cases. And the other is the wood moisture equivalent, the wood-based scale for moisture meter readings above 15%. It's easy, it's fast, it's not difficult, it's not expensive to do. So those two things I think you might want to do, as a matter of course. Now, the surface relative humidity really is the primary determinant of the bioavailability of moisture for bacteria and also for fungus. So that's you might call that a primary measurement of primary concern. And if you have equilibrium relative humidity at the surface, or surface water activity, said another way, of 0.75 or above, then you've got enough moisture at the surface if the material and if the temperature is in an ideal zone for the one of however many, 50,000 or 500,000 fungi, you're going to get more growth. So how do you measure that? Well, you don't measure it directly. There have been attempts, and a group of us have made attempts to automate that with no success whatsoever.
Well,
So
at least be honest about it, Lou.
Oh, well, try and be honest. But the way you can approximate that is to look at the surface temperature. You take a reading of the surface temperature, and that's cheap and easy to do with a surface IR thermometer. And then you compare that to the dew point temperature in the surrounding air. And then you can plot those two things on a site chart and see how close you are to an equilibrium relative humidity of 0.75 or above. So there's a little procedure in the report that shows you how to do that simply. I wouldn't encourage that as a usual thing to do, but it is maybe a way of showing people, in a very fundamental way, why it is that mold is growing there and not the other place, even though the relative humidity in the building is, not all that high. You can do that way.
Okay. And, for those that have listened to some of your previous interviews here, and especially the mold EPA's moisture control guide, in that moisture control guide, we talked about 55% dew point, and you've come in at 60 on ASHRAE. I'm just wondering if you could tell us why the difference.
It's a great question. When the ASHRAE standard changed to a 60-degree Fahrenheit dew point maximum, which is what it is now, there was a lot of pushback on that, really from people that are quite familiar with the ASHRAE guidance on humidity control, published quite widely. Also, the GSA's guidance on humidity control, the P100 Federal Facility Standard, has 55 as a maximum, and that's a baseline. You can do better than that, but shouldn't be any worse than that. And also the EPA's guidance on moisture control in buildings says 55-degree dew point. Here's the deal. when something is going into code, into building code, which is likely to happen from ASHRAE standards, you really have to balance all the different possibilities and create a minimum acceptable level that you're not forcing society to get good. You're just showing society what's likely to be bad if you don't comply with it. That's a big, big difference. Okay, so a 55-degree dew point is 75 degrees Fahrenheit, 50% relative humidity. 75, 50 for a design point. Yeah, that's pretty typical. It's pretty easy to do. So all the ASHRAE guidance and the GSA and the EPA is saying, well, just do what you usually do. 75 degrees, 50% RH from a design point of view, you're going to be fine. But for code, and especially since the ASHRAE requirement now calls for maintaining that maximum dew point during unoccupied hours, which is a big change. We said, let's be a little bit more lenient with that with respect to energy and also equipment and also operation, and say 60 degrees really where it's going to begin to be a problem if you don't have equipment in the system that can accomplish that during unoccupied hours. Probably going to be a problem or increased risk of it becoming a problem. So that's why the 60, it's an upper limit. It's easy. It's dead easy to do from a design perspective. Any engineer who can't design for a maximum 60-degree dew point is saying they're not capable of achieving 75, 50, which would be an unfortunate thing for a designer to say.
Okay, and that change of requiring that during unoccupied times, has that been a big change?
That's a big deal. And the reason it's a big deal is because most systems are, I would say all systems are designed for peak conditions, for the peak load conditions. And then they might be checked at what they call off-load conditions. In other words, slightly less severe cooling requirement or heating requirement, slightly less severe humidity, and so forth. But if you are tasked with making sure that the system can maintain a maximum dew point during unoccupied hours, effectively, what that means is you're going to need something, some component, some control, some combination of equipment and control that is going to be able to take water out of the air no matter what else is going on. So no matter what the thermostat set point is, no matter what the call for cooling is, you're going to have to be able to take water out of the air during unoccupied hours when you reset the temperature. And that will solve our problems.
And that's going to require dehumidification.
Yeah.
Most of the time, right? I mean.
Well, no, not most of the time. The requirement is only, and really the concern is when the outdoor dew point is high. So it's not like you have to run the dehumidifier at all times.
Right.
And hopefully you stop doing needless ventilation when no one's in the building. It'd be a good time to save some energy by not ventilating the building if nobody's there. So when that's true, then you don't have a terrific moisture load. So the dehumidifier isn't going to work very hard. But if it's there, it'll solve that problem.
All right. Well, we got to stop for halftime. I've got a couple questions from listeners here, but very interesting so far. We'll be back with the second half of our interview. We've got Lew Harriman talking about damp buildings, human health, and HVAC design.
IAQ radio industry sponsors are Particles Plus engineers and manufacturers of feature-rich particle counters and air quality monitoring instrumentation. Learn more at particlesplus.com. Count on us. Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions available at healthyindoors.com. And AEML Laboratories, free FedEx shipping, great pricing, same-day results, and never a rush fee. Learn more at AEMLinc.com. Association sponsors are the Indoor Air Quality Association, a multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Learn more at iaqa.org. The American Industrial Hygiene Association, AIHA, Healthier Workplaces, a Healthier World. Learn more at aiha.org. And RIA, the Restoration Industry Association, the granddaddy of the restoration industry. Network with leaders. Learn more at restorationindustry.org. SIRI, the Cleaning Industry Research Institute. See more deeply through science and research. Learn more at ciriscience.org. That's CIRI science.org. ACGIH, advancing the careers of professionals working in the environmental health, industrial hygiene, and safety communities. Interested in defining their science at acgih.org.
All right, we're back with the second half of our interview. We've got Lew Harriman. I'm going to turn it over to the Z-Man in a minute. But before we do, Lew, I wanted to follow up real quick on what we were just talking about. First, I want you to talk a little bit about time and how important time is. You've done that to some degree, but I just want to make sure we emphasize that. And also, are these yellow lights or red lights, these 4 points we've just discussed?
Answer the second part of that question first. They are yellow lights. They're not red lights. Don't get excited. Don't panic if the indoor dew point is above 60 degrees Fahrenheit for a day or two. It's no big deal. If it was 80 or 90 degree dew point indoors, then that would be more of a red light. That number one. But in terms of number two, the amount of time required. You notice that there's no quantification of the amount of time required in that report?
Yes, sir.
And that's because it's so variable depending on all the other interacting factors that we thought it would be a bad idea to do that. But we tried to get to that by saying persistent, which is, become normal over, it's become typical over days and weeks and not occasional excursions into those areas.
Excellent. Cliff, let me turn it over to you.
Thanks, Joe. Last week, we had Dr. Stephanie Taylor, and she brought something to mind that I really hadn't thought about before, and it was the fact that relative humidity indoors between 40 and 60% has been proven to help fight airborne infections. And she kind of talked about the effect on mucus and cilia and how it did that. And I just wondered if you could comment on it. And my question is similar to one that was texted in, and I'll read that one to you. Hi, Lew, COVID is still going crazy since we passed the magic line of 40% RH. What's your opinion of the ETF recommendation, 40 to 60 RH to control COVID? Do we really need to spend money adding humidification instead of addressing the building factors known to spread COVID-19?
Sure. So a great question. And Stephanie has done a great job of highlighting the fact that at very dry conditions, the epidemiology is quite clear, which is that at very dry conditions, there's an increased risk of airborne transmission of infection. I think any parent knows this. There is such a thing as flu season, and so that's definitely true. That's true in general terms, and it's true when you have lots of people inside, when one person can be transmitting to another. So that fact is more important in some buildings and in some situations than others. With respect to COVID-19, it's quite a bit different. The science on COVID-19 is quite clear that the virus is very persistent hours in the air at 50% relative humidity. So humidifying is not going to help us with COVID-19. That said, it's probably a good idea to revisit ASHRAE standards to think about higher humidity for certain types of buildings when it's dry outside, and therefore it's going to be likely drier inside, especially things like schools, maybe dormitories, military barracks, places where people kind of have to be, and they're going to have to accumulate for long periods of time with each other, and pass viruses back and forth through the air. Probably a good idea. COVID-19, no effect that anyone has been able to validate with either science or epidemiology. It's true that for COVID-19, there has been an association, especially early on, between indoor environments that tend to be dry, such as those in the northern tier in March, and COVID-19 infections. But that's much more easily explained by the fact that people spend more time indoors when it's cold outside. And now we can see that in the southern tier, where people are spending more time inside with air conditioning and in buildings together, that sure enough, we've got increasing rates there. So the association with relative humidity indoors, there isn't any that I believe is relevant. So this does get to a matter of interpretation of current understanding, and there are many judgments on that other than mine, but that's my judgment. Is that
No, but thank you. I think it clarifies it for me, and I think it clarifies it for our listening audience as well. So thank you.
Great. Yeah.
Joe?
Lou, let me ask, does this apply to, well, let's go back one. What has been the result of the report, if any? I mean, has anything changed as the result of this report coming out?
Well, it is early days because the report was published within ASHRAE quite a long time ago, but only within ASHRAE committees. So what we needed to do is get this out into the public, and the ASHRAE Special Publications folks were able to take this report and get it out into the public beginning in March of this year. So just in time to be overwhelmed by the information about COVID-19, we have this special report that relates to dampness in buildings, which is quite a different matter. So it's relatively new. That said, there has been a very significant change within ASHRAE. And that is that ASHRAE standard 62.1, which is the standard for designers for designing ventilation systems, is now different. And that standard calls for the designer to ensure that the system that he or she designs will be capable of ensuring that the dew point indoors is below 60 degrees Fahrenheit, no matter what the operating conditions are. So during unoccupied hours as well as occupied hours, the designer is charged with making sure that the system design will keep the indoor dew point below 60 degrees Fahrenheit whenever the outdoor dew point is above 60 degrees Fahrenheit dew point. It doesn't have to be doing it all the time, but if it's really soggy outside, then indoors it needs to stay dry. Dry is defined by a maximum of 60 degree Fahrenheit dew point. That's a big deal. That's a big change.
But does that apply to all? It doesn't apply to all buildings now. Is that accurate to say, or?
Well, that's true. 62.1 is a standard that applies for designers, and it's not the law. It's just ASHRAE's guidance as to best practices to avoid major problems. So unless 62.1 is incorporated into the building code locally, then that doesn't necessarily, it's just like what all your colleagues are going to laugh at you about if you don't follow. When there's a problem, they'll say, well, yeah, did you follow 62.1? And then you can admit that you did or didn't. But it's not, nobody's going to come after you, from a legal point of view, if it's not a legal requirement and doesn't necessarily mean. So that's number one. Number two is that 62.1 applies to commercial and institutional buildings. It does not apply to residential buildings, unless they're high-rise residential buildings, and that's a little squishy. So it doesn't apply to houses. It doesn't apply to You know, low-rise condominiums doesn't apply to that. So that, and the other thing is that 62.1 is a standard that applies for designers. Now, the fact of the matter is, it's widely respected in the industry as a guideline for building operators as well, but that's not, it's not a standard that applies to operators. It's just showing them what a designer ought to do so that the building can be operated in a reasonable way. So it does not apply to existing buildings. It does not apply to residences. But if you're designing a new system for a building, a nice new system, or if you're designing a new building, it does apply to those.
Okay. Lou, Cliff, let me turn it over to you for a minute because we've got a couple text questions. You've had a better chance to look at them than I have. Maybe you could pass them along to Lou.
Okay, let's see. Hi, Lou. My question sent via email is about COVID-19. How much should I invest to address air quality to reduce COVID-19?
Okay, so that's a pretty open-ended question. And the first thing I'll say that although I'm a consultant to the ASHRAE COVID-19 task force, I don't speak for that task force. Much less do I speak for ASHRAE. Okay, so now we're in the realm of what does Lew think? Okay. To be really clear. Okay, so with respect to COVID-19, a different subject than dampness. All right, I think to me it's reasonably clear at this point. Couple things, you know, COVID-19. The problem is when you're doing what I'm doing now, which is spraying, you know, aerosols into the air, you know, droplets and little small things, and then droplets that become really tiny and then persist in the air forever. When people are doing that, when they're indoors, then it's a good idea to take that stuff out of the air. Now, how do you do that? You know, three things. One is you use as much ventilation as you can, as much ventilation as the system can handle without causing other problems. Because then you can dilute the concentration of the viral cloud. You can reduce the concentration of that viral cloud and therefore reduce risks. So that on the HVAC side is a good idea. Second thing you can do is you can use filtration that will get 80 to 90% of any little guys out of the air if that air goes through the filter. And that means using MERV 13 filters as a minimum in your central HVAC system if you have a central HVAC system. If you don't have a central HVAC system, let's say you're in a residence or an office and you've got wall-mounted units or I don't know, hotel or through-the-wall units or something like that, then it's a very good idea to use a portable HEPA air cleaner and get the biggest one you can afford, because then you can run it at a nice, low, quiet speed and you won't be turning it off. You'll be leaving it on, which is what you want. And then finally, another great idea is to use upper air disinfection using UVC, ultraviolet in the C band. A little tricky to do because right now that's about a 10 to a 14-week delivery on those wall-mounted fixtures that basically shine UVC up towards the ceiling, not towards your eyes. They shine up towards the ceiling and therefore be able to get rid of viruses and bacteria in the upper air of a room. Really good ideas. So those are ways to improve the indoor air quality. Most important is none of that stuff. None of that stuff is don't gather indoors in large groups. And if you have to gather indoors with anybody and you don't know them and they don't know you and they're not part of your pod, then you wear a mask. Those are the two things that are going to solve your problem. Don't rely on HVAC to do magical things to kill this bug or get rid of it, because it's not going to work very well if you're in groups and you're talking together and you're not having masks. There's nothing that can save you from that. You've just decided you want to be at the highest possible risk.
Joe?
Lou, I've got one more quick text question from a listener, and I think you can do it pretty quickly, and then we'd like to go to a roundup. Has there been any hard data on how much of the virus returns from the air handler?
Sure, there actually is, not very much, but some. So the data that we've got on filtration effectiveness is twofold. One is that MERV 13 filters in HVAC systems are very likely to get a very large proportion of the viruses out of the air if there are any that happen to get sucked into the system, which, by the way, is not very many from what we can tell. Number two is that without filtration, the virus can, or at least the virus is represented by viral RNA of the COVID-19 type, it can be found on the discharge side of the system. In other words, on the supply air diffuser, you can find you can find some RNA. Now, is that effective? Probably not. Is it a lot? Probably not. Is it a question? Is it a problem? Probably not. Okay. But all those things can be dealt with by using MERV 13 filters, which are going to get 80 to 90% of the little guys, even the little guys, out of the air. So HVAC,
right.
not a big risk here. It's probably a big help because it's going to give you some filtration, and any filtration is better than no filtration. But if you're not wearing a mask, you've decided you want a big risk.
There you go, Lou. Hey, Lou, we're going to go to the roundup, but before we go, I want to make sure that I ask you your takeaways on the news, on the publication, the special publication. But let's go to the roundup and bring in Pete and give Cliff a last shot too. Pete, do we have you?
Yeah. Can you hear me okay?
I hear you fine, Pete. Welcome back.
Yeah. Yeah, thanks. So listen, I'm happy that you guys did the show with Lou this week for a number of reasons, because normally the beginning of August is when you take your summer vacation and do Flashback Fridays. But since there was no summer camp this year, Lou, you substituted for all these kind of talks that we would have at summer camp every year. So I really did enjoy the interview. So here are a couple of little notes and a couple things I got. First of all, I love your new bio, Lou. I hadn't seen that one yet, and I love that you started off by saying that you've been doing some research in your basement. It seems like a lot of really important people these days in the news have been spending time in the basement, but hopefully you've been doing some good work down there. The other thing that I didn't realize you were a woodworking guy too. I never knew that. So that's something you and Mickey have in common, because of course Mickey's a big woodworking guy also. And I guess now that you're in this retirement age, you're really been able to spend your time. And when you're retired, isn't it amazing how you tend to be more busy than when you're actually working?
Well, I'll tell you, Pete, I haven't been that as busy as when I was working, and the big deal is that you're not thinking about all of your clients' problems and opportunities 24/7. So it's really very, very pleasant. But woodworking is something I've done for a lot of years, and in fact, in college I spent probably more time in the student workshops than I spent in the library. I'm going to have to admit that. The metalworking shop, the jewelry shop, and the woodworking shop, we had all three, where I went to school, and that's where I spent my life making stuff. And now I get to do it again.
Well, I wasn't aware of that, so I thought that was kind of interesting. But listen, I guess you're the first one of the original Moisture Mob guys that came back to do another interview. The Moisture Meister. I think we agreed that was your name. You're the Moisture Meister. Now, listen, I tell you though, on a serious note, on some of the stuff you've been talking about, I recall when ASHRAE first came out, with the damp building document. That was kind of probably during several years ago when the mold started to become such a big issue, or mold was an issue for a while, but they kind of took a stand on it, because I remember when it first came out, you actually presented it at one of the WLS classes. And so I think it's interesting the way ASHRAE has moved into doing these best practice documents as versus their standards, which primarily serves the engineering segment and the builders and whatnot. It was a very interesting statistic with the hits on the website. In 4 months, 500 million versus, less than 1 million all of last year, and a lot of it with the COVID. And, one of the things that had struck me, Lou, is that with organizations like ASHRAE and ANSI and ASTM that really go by their acronyms, nobody ever really talks about the A standing for America anymore, because they seem to be really internationally accepted, and that expertise has kind of helped on a global scale. I was going to ask you about 62. I made some notes on this when you first started talking, but before the interview was over, you've already addressed 62. And I remember how contentious the peer reviews were during the 62, when it went out for public review. And the big argument at the time was, should there be kind of emotional and health type language in a document that was primarily a technical, an engineering document. And I think that held it up. But now it seems that ASHRAE has kind of addressed that by coming out with these guidance best practice pieces to deal with those kind of issues versus kind of the code language that you talked about. So I think that's really good. And I was happy, to see that the organization has done that. And I think it'll help industry in a lot of these multidisciplinary things. And you're really the perfect guy to facilitate that stuff. So I give you kudos on the job that you did with that, Lou. Couple last points. The unoccupied building, that whole requirement, which even though it's not a code, I think is really important, particularly in the schools. One of the things that I always remember that Mike McGinnis talked about over the years, he does a lot of schoolwork in New Jersey, and they never really seem to adjust the HVAC systems, whatever their settings are, to deal with the high humidity in the summer times. And what happens, particularly, they always clean their carpets during the summer, and there's never enough ventilation. And, normally the carpets would dry without a problem, but it was amazing how much mold work they would wind up getting because they dumped all this moisture into the buildings and they never got it out. So I think that new requirement, if people start kind of using that probably will be very helpful in that regard. And I think that was something that was overdue. And I'll kind of close by saying, this is summer camp week, and this last Wednesday would have been Sicilian night. And those of you that are familiar with that in summer camp know I got a lot of those recipes from my grandmother. Well, the one thing that I like to say about grandmothers, and Cliff, this is a shout out to you. Cliff always talks about low-tech solutions, right, to things. And sometimes we make things too complicated. Well, the one thing I remember about my grandmother back in the days, in the flu season, when it was real dry outside, they would have the old steam heat in these buildings and lead paint, which of course it would make it crack. And that's another whole series of issues before they ever dealt with that. But Grandma's way of dealing with that was to take the old cans of Maxwell House coffee, the one that was good to the last drop. She put some water in it, and they put it on top of the steam radiators, and it added a little humidity into the air, and that kind of seemed to make it better so that our eyes wouldn't scratch and we could live during the time. So we didn't need consultants, and we didn't need, fancy specifications and dehumidification equipment. We just needed some grandma common sense. So anyway, thank God for that, and long live grandmas. So anyway, I'll turn it back to you guys.
Thanks,
Anyway,
Pete.
I enjoyed it, Lou, and Joe and Cliff. It's always great, you guys bringing the guys back who really know what they're talking about and can talk in simple, plain language. Thanks, guys.
Thank you, Pete. And
Thanks, Pete.
Cliff, do you have a final?
I do. Lou, I was thinking about what you said in terms of the fact that RNA from COVID has been found on supply registers. And it seems to me that if point A, where these, where this viral cloud is being generated, is closer to those registers, in the room itself, it would seem to me that it would most potentially be more likely that those particles were in the air and somehow were entrained by airflow on those registers, rather than running all the way through the system and then back again to the same room. But, just a thought. So
I think it's a very good thought, Cliff. So I think there's a lot that we don't know and are never going to know about that stuff. So the bottom line is, let's wear masks indoors.
And HEPA filters, absolutely.
And HEPA filters, portable HEPAs are cheap. We with our stimulus funding, we bought 4 of them, giving them to people that are at risk, because that's what we need to do for each other.
Let me get one final question and then give you the last word. It's a text question, but it's something I've been seeing everywhere. And in fact, I just had an email from Luke Gard, who does a lot of work with schools. They're being sold on this bipolar ionization. And this question is, what do you think about using that bipolar ionization to reduce the amount of outside air being recommended that could really increase the amount of moisture in the air in warm weather?
Okay, so I'll be really clear about this, but also really clear that it's me and not ASHRAE, and not the COVID-19 task force. Don't do it. Don't do it. Don't do it. You need dilution as much as possible. Bipolar ionization may or may not be a good idea. It may or may not be effective in terms of allowing the particles to conglomerate and therefore be more easily filtered. It certainly does not kill anything any quicker than anything else. The tests, the third-party tests that I've seen by one of the vendors are very clear about that. It's no big deal. Very unconvincing evidence in my view that it does any good for anything other than helping to agglomerate particles. Don't do that. Do not do that.
Thank you, Lou. I appreciate it. Hey, Lou, before we go, your quick summary takeaways from this document.
Sure. I think number one, the document is free as a PDF. ASHRAE has made it free as a public service. So feel free to either download it from the IAQ radio website. You are welcome to do a Google search based on that title, and you'll come to it really quickly. You can email me if you want, Lew Harriman at masongrant.com, and I will send you a copy of it. There's no copyright infringement. By all means, give it to all your friends and your grandchildren and your great-grandchildren so that they can memorize it and benefit from it, number one. Number two is that if you are a building owner or a building designer, if you implement the new ASHRAE standard 62.1, specifically 62.1 2019, that's the current one, section 5.10, if you just say comply with this, designer, and operate in accordance with this, then you're going to solve a big problem. And it's written in code language. It's written in specification language. So just say, do this. Standard 62.1 2019, section 5.10. Do this and prove to me that you did it and you are doing it, and then you will greatly reduce the risk of dampness related problems indoors, because you'll have the capacity to dry stuff out no matter what, no matter how wet they get. If you do that, you'll be able to keep it dry. The surfaces dry means you're not going to have a problem with mold and with bacteria. Yeah. In all of the hidden surfaces, you got to have that caveat there, and it's easy. Just make sure you got a dehumidifier and you make sure you keep it dry when you need to, and don't worry about the temperature. You'll be good. So those are my takeaways that I'd like to have people remember, is that you can avoid these problems with a little bit of attention. And for new buildings, it's dead easy to include that in your spec, and you're practically done.
Lou, always a pleasure. We really appreciate you joining us in spite of you being retired. And also, as an industry, I think we all, I'll say for everyone, thank you for all of your contributions to the industry over the years. It's not the first document you've been a big part of. You've written books. You've been a big part of ASHRAE and other organizations as well over the years. And I, for one, appreciate your contributions. And I also appreciate just the way you go about life. You're just a easygoing, great guy to talk to, and always willing to share. So thanks for being that, and for joining us today on IAQ Radio Plus.
Thank you very much, Joe. Appreciate it.
This is Radio Joe Hughes saying thanks to this week's guest, Lew Harriman, to my co-host, the Z-Man, Cliff Zlotnick, to John, you got to have faith at the controls. Most importantly, our growing group of loyal listeners. We're going to be taking our summer break for the next 3 weeks, but we'll put up a couple of great flashback shows. I know people like the flashbacks because they know that Cliff and I have looked through and picked out one that we really think is a great show for you to check out. So look forward to seeing you back here in the not too distant future. Have a great weekend and come back for the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reed saying thanks for listening.